Patty Simpson with Simpson Math. In this video, we're going to use the empirical rule to find the probabilities. So here I've drawn a couple of normal distributions. In this one, I've drawn a normal distribution with a mean of 18 and a standard deviation of 1. Remember, this notation just means normal with our mean and then our standard deviation. And here I drew that normal distribution, nice bell-shaped curve, with our mean in the middle, and then we counted by ones, that standard deviation, the distance from the mean. So I drew a couple of those, and we want to know what is the probability that we find a value, random variable, if we randomly select from whatever it is, our data set. What's the probability I get a value that is greater than 18? Couple of things to remember. We know that the area under this entire curve is 1. And so we can begin to find the area between certain distances. And we've done that with the empirical rule. The empirical rule tells us that 68% of our curve lies within 1 standard deviation. Within 2 standard deviations, 95% of our curve is there. And between 3 standard deviations, 99.7% of our data is within that 3 standard deviations. So if we look to see what's the probability I get some random variable above 18, we'll notice that if I color in from 18 over, I'm looking for this area underneath my curve. From this 18 over is the area I'm looking for. And how much of my curve have I covered? Notice that I colored half of it. It's this nice symmetry. So that means that half of it is above the mean and half of it is below the mean. So the probability I get something greater than 18 is 50%. Or you could say 0.5, because those two numbers are the same thing. So 50% of my data will lie, or 50% of the area under the curve is above 18. Well then, how much is below 18? Well, since this is symmetric, it is exactly the same, and 50% is also below that mean. Then, let's look at the probability that if I randomly select a piece of data from my data set, what's the probability I get between 17 and 19? So let's look between 17 and 19 here. And notice that that 17 to 19 is 1 standard deviation from the mean. That 17 to 19 is 1 standard deviation from the mean. So my picture's not all that great, but you get the idea. So this is 1 standard deviation is 68% of my curve is there. So this is 68% chance, or 68% of my data falls within that range. What's the probability that I get between 16 and 20? So now I'm looking at between 16 and 20. By the way, if 68% is here, how much does that mean has to be out there? You know, if 68% is within 1 standard deviation, then outside, from the outside, I would say 100%, or 1 minus that 0.68, or minus the 68%, gives me 32%. So on the outside edges here, there's 32% chance that I get something that's below 17 or above 19. So from that 68, not only can I tell the 68%, but I can also see on the wings, because the whole area makes up 100%, or one whole thing. Let's look at 16 to 20. So if I look at the area between 16 and 20, again, notice that I'm within 2 standard deviations. This is 1 standard deviation. This is 2 standard deviations, or 2 SDs. 1 standard deviation would be better notation, and 2 standard deviations. So within 2 standard deviations from the mean is 95%. So this area underneath the curve, or the probability that I choose a data point between 16 and 20, is 95%. What about on the edges then? What's the probability I get something below 16 or above 20? Again, I could subtract off this from the 100 to find out how much is out there. So on the outskirts then would be 100 minus 95%, which gives me 5%. Only 5% of my data is above 20 or below 16. Here, if I look at 15 to 21, notice that 15 to 21 is out 3 standard deviations. 3 standard deviations by the empirical rule tells me that 99.7% of my data is between those 2 values, or 99.7% of my area under my curve. Or you could write that as 0.997. Those are the same numbers. This number and that number are the same thing. So how much is out here? How much is below 15 or above 21? What's the probability I get something on the outskirts? Well, I could just take that 1 minus 0.997, and that turns out to be 0.003, or that 0.3% of the time, teeny tiny amount of the time, am I going to get anything that's below that 15 or above that 21. So this is how we can use the empirical rule to determine some probabilities. Let's look here. I want to know what's the probability that I get. By the way, I now have a normal curve with a mean of 12 and a standard deviation of 1/2. So here my mean is in the center, and I've counted by 1/2. Those distances are 1/2. That's what that standard deviation is the distance from the mean. So I want to know to go from 12 to 12.5. So from 12 to 12.5, what's the probability that I catch a piece of data between here? Again, probability and area are related. So I'm really asking how much area under the curve is between 12 and 12.5. Now, this one is out 1 standard deviation, but it's different from what we did over there because I didn't go back 1 standard deviation as well. That 1 standard deviation that makes up the empirical rule would go from 11.5 to 12.5. That would make the 68%. Notice that this is half of that. If I were to color the other part, this part here makes up the 68%. For some reason on the left, I can't make it nice and straight. Here, this would make up the 68%. But I'm taking that and I'm chopping it in half. So half of that 68% leaves me with 34%. So here I'm going out 1 standard deviation and splitting it in half to get the 34%. This is just half of that 1 standard deviation from the mean. So the probability I get something in there is 34%. Notice that probability would be the same if I asked what's the probability I get something between 11.5 and 12. This is also 34%. Because this 34% plus that 34% makes the total 68%. Let's check between 12 and 13 then. I want to know how much area under my curve, or what's the probability I get a piece of data between how much of my data, what percent of my data is between 12 and 13. Well, again, looking at my empirical rule, if I go out 2 standard deviations, then I have 95% of my data, but I'm only looking at half of that. So I'm going to take that 95% and cut it in half. And this percent is 47.5% of my curve is there between 12 and 13. So 47.5% of the time I would expect, if I randomly choose a data point in this data set, to get something between 12 and 13. Well, what about then between 11 and 12. That's the other half of this, so this also would be 47.5. That 47.5 plus this 47.5 makes up the full 95% from the empirical rule. Let's look at between 12 and 13 and a half. So here I've now gone out 3 standard deviations, but it's only half of that. If I went out 3 standard deviations on both sides, it would be 99.7% of my curve. But here I'm only looking at half of that. So I'm taking that 99.7% and dividing it by 2. So we get, well, that's 4, 9 with 1 left over, 8 with 1 left over, 5. So 49.85% of my data lies within between 12 and 13.5. That means that between 10.5 and 12 is also 49.85. If you take that 49.85 and add it to that 49.85, it's 99.7%. So the probability I get something between 12 and 13.5 is 49.85. Now we can use this idea of the empirical rule and being able to split things in half to help us find other things as well. So for here, I'm looking for the probability that if I randomly choose a data point from this distribution, what's the probability that I get something between 11.5 and 13? So in other words, I'm looking for this area under the curve here. Well, we can begin to use some of the things that we've had before. So notice that, first of all, it might help if I said this part is the mean. This is 1 standard deviation. This is 2 standard deviations. But this direction, I went back 1 standard deviation. So there's several different ways, and people do it different ways. Maybe you look at this and you say, well, I know this part is 68%, and then I add whatever that little piece is. But from above, we've done a little of these pieces. We know that between 12 and 13, if I look between 12 and 13, I know that that's 47.5%. And then if I look between 11.5 and 12, well, that was the same as doing between 12 and 12.5. So between 11.5 and 12 is 34%. So if we add those pieces together, this piece is 34% and that piece is 47.5%. So I have 34% plus that 47.5% gives me a total of, let me carry one, 81.5%. So 81.5% of my curve is here between 11.5 and 13. So you can use your empirical rule to help you to find different probabilities between our standard deviations, between our values, if you just use those standard deviations to help you. And you can even, because it is symmetric, you can begin to look for halves to help you to determine those things. Math Made Simple is some math. Thanks for watching.